Hi geometry students. Since the Scribbler problems might have been a little unclear and I know this was a tough section, I'm going to review a few of the homework problems from 11.7. So if you had any problems with any of them, I want you to watch this video. Make sure before you start, you can pause it now if you need to, get out your book, open it to section 11.7 and get out any homework you've already done. These guys here have been my elementary students, my 2nd and 4th grade math videos, but they decided they were ready for high school, so they're going to be joining us for this week's lesson. Okay, I'm going to work the problems out on this paper. Hopefully you'll be able to see everything. I'll try and keep my hand out of the way. So you should have your book open to page 746 and have out your 11.7 problems. I'm going to work problem number 7 first. So this is section 11.7. I'm going to do problem number 7. Okay, so first of all, let's see what it says. It says, for these exercises, are the two figures similar? If so, give the scale factor of the first figure to the second figure. If they're not similar, then you'll just say no. But you have to show your work. So the way you know that any two things, just like when we were doing triangles, you knew they were similar if all three sides were proportional. And so what we're going to do is we're going to do the same setup for this. So we're going to call it, and they said from the first to the second. So we're going to figure out what the scale factor of the left one, the left over the one on the right, because that'll be the first one to the second one. And what we're going to do is, for number 7, because it's a box, we have to look at all three of the dimensions. And so the only way it could possibly work if shortest is with shortest, medium with medium, longest with longest, no matter which way they orientate the box. So we're going to do short, medium, and long. This will look really familiar to the stuff we did for similar triangles. So for the left one, looks like it's 4 inches, 6 inches, and 8 inches. From smallest to biggest. And then we're going to make our ratio. So this is a ratio of the shortest sides, the ratio of the medium sides, and the ratio of the longest sides. If all three ratios are the same, then we know they're similar. So for the right triangle, it looks like it goes 6, 9, 12. Notice I'm not setting them up like length, width, and height, because that doesn't really matter because you can always turn the box. So all of the inches cross out. 4 over 6 reduces to 2 over 3. 6 over 9 reduces to 2 over 3. And 8 over 12 reduces to 2 over 3. So because the ratio of the corresponding shortest sides, medium sides, and longest sides are all the same, we know they are similar. And the scale factor, you can write it 2 to 3, or with the colon, or, but you have to show this work. You have to show that the reason they're similar is because the ratios of the corresponding sides matched up. So that's number 7. Let's take a look at number 12 next. That was one of the ones you had to do. So let's first of all find out what they're asking. They're asking to find they tell you that the figures are similar, and they want you to use the information to find the scale factor of smaller to larger. Since the instruction said smaller to larger, we're going to put our smaller on top. And so we know the scale factor is A over B. So, and we'll know we're going to put the smaller one on top, the larger one on bottom. But we don't know the scale factor, that's what we have to find. But we do know a relationship between volume and scale factor. So we know the volume of the smaller over the volume of the larger equals the scale factor cubed. Okay? And so let's go ahead and simplify this. So the volume of the smaller is 216 inches cubed. The volume of the larger is 343. And we're lucky because they made these numbers super simple. So those cross out. And we know that equals a cubed over b cubed. And we need a over b. So the way you get a cubed to change to a is you cube root it. And whatever you do to one side of the equation, you got to do to the other. The only way to get b from b cubed is to cube root it. Cube root of a cubed is a. Cube root of b cubed is b. Cube root of 216, if you've got one of these calculators, just a reminder on how to do cube roots, is you go to the second function. You go to math, and then you scroll down, and number 4, you see that little picture, it says cube root, and then a square root sign, and then parentheses start. We hit that, and the cube root, and the number we want to cube root is 216, and we're lucky because it worked out clean. We're going to do the same thing for the 343. Math. Scroll down to cube root. 7. Okay. So since the question is, what's the scale factor? Scale factor is 6, 7. Okay. So that's 7 and 12. Now we're going to move on. You had to do 15 and 17, so I am going to work 16. But these all work exactly the same way. Okay, so first of all, let's read the instructions. They tell us that they give us two surface areas and they tell us the figures are similar. The volume of the larger figure is given. Find the volume of the smaller figure. Okay, so we know that the formula that we're going to need to finally do it is going to be the volume of larger over the volume of the smaller equal a cubed over b cubed. And what is a over b? Not numbers, but what is it in words? So I want you to think of it before I say it and then see if you get it right. A over b is the scale factor. I want you to keep repeating that over and over again. It's not just a bunch of letters on top of each other. That's the terminology we're using for scale factor. So now we've got to figure out what the scale factor is. As soon as we get it figured out, we can cube it and we'll be golden. So for problem 16, they give us the two surface areas. So we're going to make those a ratio. And since we had larger here, we'll go ahead and do larger on the next one. So SA of the larger over SA of the smaller. We write the formula first. We always follow our formula rules. Okay. And now we're going to plug in what we know. We know the larger is 1728 meters squared. And we know the smaller is 192 meters cubed. Okay. We'll take out the meter squared because those cancel. Now, if we can reduce that fraction, that'd be really nice. So I'm going to bring this over here and remind you how to reduce fractions. Okay. 1728 divided by, forgot the number, 192. And then you hit math. And then fraction is already lit up, so we want the answer as a fraction. 9. But we need it to be a fraction, so it's of course going to be 9 over 1. Sweet. It's nice when the numbers work out that clean. They don't always. We know we need a over b, so we square root both sides. A over b, square root of 9 is 3, square root of 1 is 1. So the scale factor is 3 to 1. Now we can go back to this. We can go back to our original formula right here. And we can plug in what we know and work it through. So the volume of the large one from problem 16 is 4860 meters cubed. Remember, keep the units. Over the volume of the small one equal a cubed. A was 3, so it's going to be 3 cubed over 1 cubed. Okay, so we have 9 times the volume of the small one equals 1 times 4860 meters cubed. Divide both sides by 9. And only now can I pull in my calculator. $540. 540. There were no units in the 9, so we keep these units. That's the answer. So that was problem number 16. Like I said, you had to do 15 and 17, but you're going to use the same logic. Okay. Now we're going to do a hard one. We're going to do problem 22. And problem 22 is very similar to problem 21. My guess is there's a good chance that one messed you guys up. And so we'll talk about how to handle this one. So first of all, the quickest way to do it is to, first of all, we're going to need a scale factor. We know that the volume of the larger over the volume of the smaller is going to be the scale factor cubed, right? Now, volume and capacity can substitute in for each other. So we know the volume of the larger over 16 ounces is going to equal the scale factor cubed. So let's figure out what the scale factor is. So the scale factor is going to be, if you look at problem 22, they only give us the diameter for one, but they give us the height for the larger and the smaller. So we know the height of the larger over the height of the smaller is going to be 10 inches over 6 inches. And that reduces, the inches cross out, and it reduces to 5 to 3. So the volume of the larger over 16 ounces equal 5 cubed over 3 cubed. So 3 cubed is 27. So 27 times the volume of the large is going to equal 125 times 16 ounces. Okay? We got to get the large volume by itself. I'm just going to punch all this in at once. So we have 125 times 16 divided by 27. And it wanted it to the nearest ounce, so it's 74 ounces. If you had worked it all through with pounds, then you would have had some decimal number and you could have multiplied it by 17. But it's better to convert it to the ounces first. And that's the end of 11.7. I'm going to work one problem from 11.5, just in case you got a little stuck on those. So I want you to turn in your book to the 11.5 section, and we're going to do problem 13. So everybody open your book to page 730. So on page 730, and we're going to do problem 13. Okay? So it says, find the volume of each square pyramid given its slant height, round to the nearest tenth. So the formula for a pyramid is 1/3 times the base times the height. Okay? We know it's a square. Oops, that should be a capital B. I'm doing this from memory. So let's go ahead and calculate the base first. So we know the base. We know it's a square, and each side is 23 millimeters. So the base is going to just be the base of the square times the height of the square. Or you can do side squared if you wanted. If you wanted to do s squared instead of b times h, I'm fine with that. And you end up with 23 millimeters times 23 millimeters. And if you did s squared, you would just do 23 millimeters squared. 529 millimeters squared. Okay, when the time comes, we'll take that and we'll plug it in up there. Now we're going to do the height. This is where the tough part comes in. So here's what I want you to visualize. I'm going to draw a triangle. This is going to be, this line here is going to be from the top of the pyramid to the middle of the square. Pyramid to the middle of the square. That's the height. And then I'm going to come out, and this line is going to be from the middle of the square to the midpoint of a side of the square. So I'm taking one section out of the picture that we see. Okay, and we know that's going to be, since this one's vertical and this one's horizontal, we know that's a right angle. From the top of the pyramid to the middle of the square is the height. From the top of the pyramid to the midpoint of the edge of the square on the outside is the slant height. And then this is going to be from the middle of the square halfway across, it's going to be half of 23. But we don't really need that, so we're not even going to use it. So I'm going to put 24 millimeters in here. Actually, we will need it. So we know the whole square going across was 23 millimeters. So let's divide that in half to see what that length is. 11.5. Should have been able to do that in my head, but I don't want to take a chance. It's been a long week already. Now you can use the Pythagorean theorem to solve. So we know that the leg squared plus the leg squared equal the hypotenuse squared. So we know that h squared plus 11.5 millimeters, I'm going to put the whole thing in parentheses, squared, equal 24 millimeters squared. Now I'm going to give it some numbers. 11.5 squared, 132.25 millimeters squared equal 576 millimeters squared. Okay, so we're trying to get the h by itself. So we're going to subtract 132.25 from both sides. Okay, so I'm going to subtract that. And there's no reason for you guys to get your calculators out for these. I want you to just focus on the process and spend time thinking about what we're doing. Instead of actually punching buttons. So we've got to get the h by itself. Since it's squared, we're going to square root it. So I'm going to take that number and square root it. And the square root of millimeters squared is millimeters, and the square root of 443 blah 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 is 21.1 millimeters. Okay, so now I've got a height. Now that I've got my height and I've got my base, I can plug those two things in here and solve for the volume. The base was 529 millimeters squared. The height was 21.1 millimeters. Okay. Okay. So I'm just going to keep that number times 529 divided by 3. And the answer is 3714.5 millimeters squared times millimeters is millimeters cubed. And that's the answer. Okay, that's a wrap. I will be shooting out a video of next week's stuff shortly. Bye. They are still happy, so they must have learned something.